We're going to go ahead and finish up the section 2.6 notes now. Rational functions, graphing rational functions. And I saved all three of the best examples for last. So what makes this example interesting is that the bottom of it is a quadratic. Ooh. We're going to have to factor some stuff. The directions are telling us to find the intercepts, the asymptotes. We're going to says use limits to describe the behavior at the vertical asymptotes. Well, like we will. It says, and analyze the graph. No, you know what? I don't feel like that. We're not going to analyze the graph because we just don't need to do that. But we will draw the graph of the rational function. And I tell you what, and before I use limits to describe the behavior at the asymptotes, I want to graph it. I'll do the limit stuff last. That way I have a picture to look at. It'll be a little bit easier. First things first, we're going to have to factor that quadratic that's on the bottom. So I'd be looking for two numbers that multiply to be -6 and add to -1. X minus 3 and x plus 2. I'm going to write the x plus 2 first. Of course, it doesn't matter. I just prefer it this way. There. Factored. Say this number, or this thing has two numbers that are no-nos that we're used to seeing one. But this one has two x values that I can't plug in. Two numbers that make that denominator equal 0. So it has two vertical asymptotes. I have a vertical asymptote at x equals -2, and I have a vertical asymptote at x equals +3. Since we're working on asymptotes, let's go ahead and talk about its end behavior asymptote. Well, the degree of the top is actually less than the degree of the bottom. And if you can remember back to the end behavior stuff that I did with you, we said that anytime the degree of the top is less than the degree of the bottom, automatically the x-axis is the horizontal asymptote. So this one's end behavior asymptote actually is a horizontal asymptote. It's the x-axis, or y equals 0. We have to find the intercepts. So let's go ahead and find that. We can do that without graphing. Let's find the y-intercept. That one's easy. When you're on the y-axis, something that is always true is that x equals 0. So you want to know where you cross the y-axis, you just plug in x equals 0. What you're going to get is y equals, see the top will be -1, the bottom will be 0 minus 0 minus 6. So we cross the y-axis at +1/6. Easy, right? Cool. How about the x-intercept? Or intercepts, it could have more than one. This one doesn't, but it's possible. Well, if x being 0 gives you y-intercepts, I think it should be pretty obvious that y being 0 gives you x-intercepts. But y equals a fraction. It is our rational function x minus 1 over some stuff. What is the only way a fraction can be equal to 0? Is that the top equals 0. That's it. The only way a fraction can have a value of 0 is if the top equals 0. So what number would make our top equal 0? Yep, +1. So we cross through the x-axis at +1. There. I'm going to go ahead and sketch what we know so far. Vertical asymptote at -2. Vertical asymptote at +3. An actual horizontal asymptote at the x-axis. Now, Friday we saw a graph that danced all over its horizontal asymptote in the middle, and that's okay. And the reason why that's okay is because it's called an end behavior asymptote because it describes what the graph is doing at its endings, quote unquote endings, and that would be to the far right at +infinity or the far left at -infinity. It doesn't describe what's going on in the middle, just talks about the edges. So that horizontal line is going to be approached by my graph as I go far left and far right, but there's a good chance I'm going to go right through it in the middle, just like you saw happen on Friday. Let's see. We have a y-intercept at +1/6. Ooh, okay. Well, if y equals 1 is here, then I'm like here-ish. somewhere. Make the dot really big so no one can argue with you. And we cross the x-axis at +1. Oh, yeah, so this thing, yeah, lands right on the horizontal asymptote. No big deal. We saw that happen on Friday. Generally speaking, whenever you have two vertical asymptotes, the shapes in the middle, they can really only be one of two things. The shapes in the middle will either look parabolic as it approaches the asymptotes on both sides of it, or it's going to look like a cubic as it approaches the asymptotes on both sides of it. I need a little more information to figure out which shape I'm dealing with here. So I'm going to go ahead and plug in x equals 2, just to see what the graph is doing. So plug in x equals 2, just because I'm trying to figure out what's going on. When I plug in x equals 2, I get y equals 2 minus 1 over 2 squared. What is it? Minus x? Minus 2 minus 6. So it's 1 over -4. Oh, -1/4. Let's see, trying to get to scale as possible. This will put me right around there. So what's happening is that this graph is doing something like this. Something like that. Cubic-ish in between. Because it's going up as it goes to the left and it's going down as it goes to the right. It's going to have some kind of cubic shape. Okay. Well, yes? X interrect. Holy cow. Intercept. Whoa. Ta-da. Okay. I don't spell very well. Now I need to know what's going on to the far left and the far right. I need to know where I am. Yes, sir. How did I get the -1? I'm sorry? -1/4? Oh, when I plugged in 2? Because I just did 2 minus 1, 2 squared, which is 4, minus 2 minus 6. So would I get 4 minus 10? No, 4 minus 8, excuse me. Okay. Yeah, I just had to come up here. I just couldn't see it when I was plugging it in. So is the board going to, help me today? What's going on right now? Goodness, I think it's struggling right now. I need to know what's going on the left and the right. So I'm going to plug in the numbers, I don't know, how about -3 and +4? So y equals -3 minus 1. On the bottom, I'm going to square that -3. And then it says minus that -3. And then there's a -6. It's -4 over 6. It's -2/3. So as I go this way, I ended up in the negative zone. This is -3. That put me somewhere around here-ish, -2/3-ish. And what that tells me is that my graph is going to be shaped like that, because I have to get close to both of those asymptotes. And let's plug in 4. See what's going on over there at x equals 4. So top's going to be 4 minus 1. Bottom will be 16 minus 4 minus 6, or 3 over 6? +1/2? That was quick maths, but did I do it right? Okay, cool. Up there, giving me this shape. Ta-da! Isn't that fun? We do need to describe the behavior at the vertical asymptotes, though. I'm running low on space here. So let me see if I could squeeze it in down here-ish. Do this in green. So let's see, the limit as x approaches the number -2, and looking at the blue curve, if I'm on the left side of -2, where's my graph headed? If I'm on the left side of -2, where's my graph headed? Approaching -2, but I'm getting there from the left of it. It's negative infinity because it's pointing down. So that was not ideal. I swear this board is drunk sometimes. There we go. Negative infinity. So what I'm saying is, as I'm getting closer and closer and closer to this number here, my graph is shooting down. That's what that says. Like I said, it's getting a little tight over here, but the limit as x approaches -2 from the other side. If I'm on the other side of that vertical asymptote, where are my y's going? If I'm approaching it from this side, my curve is doing this, so it's going to positive infinity. And then we have to do the same trick with the other vertical asymptote, and I'm not quite sure where I'm going to put that. Space is at a premium. All right, well, we'll just be completely all over the place. Looks like someone just threw math at the board at this point. Let's let the graph approach x equals 3, and let's approach it from the left. So we're on the left side of 3, but we're getting closer and closer and closer to 3. We're doing this right now. What are the y values doing? Does more than one person know that? Yeah. You guys can see that it's pointing down, right? Just want to make sure. And then lastly, the limit as x approaches its vertical asymptote, but on the right side, the y values are doing, as I'm doing this, my y values are doing what? Increasing up to positive infinity. Good. Wow, there's math everywhere. Wow. Thank goodness we didn't have to analyze it, right? I don't even know where I would put that right now. So questions, comments, concerns about graphing, finding intercepts, finding vertical asymptotes, horizontal asymptotes, sir?
Yeah, I was just wondering, I guess, the horizontal.
So one of the rules about in behavior asymptotes specifically says that if the degree of the top, come on board, if degree of the top is less than the degree of the bottom, automatically the x-axis is a horizontal asymptote. If the degree of the top equals the degree of the bottom, this is when you would use the leading coefficient over leading coefficient. Right, so leading over leading. And then when the top is bigger, you don't have a horizontal asymptote. When the top is bigger, that's when we get slant asymptotes or quadratic or cubic asymptotes at that point. Polynomial asymptotes is what we would call them. Okay? All right, let's do this one again. And let's see, does it tell me to analyze it? Yeah, it does. Not anymore, it doesn't. There we go. Not trying to analyze anything. Oh, I got a quadratic on the, yes, sir.
When you're doing the limit, how do you tell if it's from the left or right? Like, how do you say from the left?
Well, if you're trying to say from the left of a number and you're doing limits, you put a little minus sign in the superscript position. So it would be like from the negative side of that number is what that means. So right here, this little symbol told me I'm to the left of -2. Because it's like, oh, that's where the more negative numbers would be. And if you put a little plus sign in the superscript, that's on the positive side of the number, meaning if I stay on that side, that's where my positive numbers would be. So this one is a quadratic in the numerator and the denominator, which means we get to factor twice. Yay, factoring! All right, numerator has a GCF of 2. Hey, look, difference of 2 squares. Hey, look, a difference of 2 squares. But at least they both factor easily, correct? So the top is going to have a 2 hanging out, and then an x plus 1 times x minus 1. At least it was easy to factor, difference of 2 squares. And the bottom x plus 2 times x minus 2. Awesome. Once again, we have two x values that would make our denominator equal 0. So we have two x values that are no-nos, two vertical asymptotes. Going to occur when x equals -2 or when x equals +2. Now this time the degree of the top is equal to the degree of the bottom. So now we get to use leading coefficient over leading coefficient. This one's leading coefficient is a 1. So again, we do have a horizontal asymptote acting as an in-behavior asymptote, and this one's going to be y equals 2 over 1, which is just y equals 2. Okay, how about the intercepts? Y-intercept, same way it was last time. If you want to find the y-intercept, you just plug in x equals 0. Hey, look what happens if you plug in x equals 0. You get -2 over -4. You see this?
I think your active board
If the active board keeps acting like this, I'm going to have the aneurysm. Anyway, what did it give us? It gave us y equals -2 over -4, which is just +1/2. So we have a y-intercept at +1/2, and x-intercepts this time. You know what? That's why I got myself in trouble, because last time I just did y-int and x-int. There we go. I don't know. And I tried to spell it out and got caught. X-intercept is going to happen when the top equals 0. That's going to happen twice. What two numbers can make the top equal 0? -1 and 1. This one is two x-intercepts. Cool. So we have asymptotes, we have intercepts. I say we go ahead and plot that stuff right now, see what's going on. What x values do I care about? -1 and +1. Got a x equals 2 and x equals -2. I'm going to go ahead and throw a 3 and a -3 on there. And y value of 2 is a horizontal asymptote. Okay, we got everything we need. Let's see. One vertical asymptote, two vertical asymptote, and the horizontal asymptote. Let's plot some stuff. Y equals +1/2 is going to be our y-intercept. That's right around here-ish. Make a big dot so no one can argue with you. Oh, and you're going to cross the x-axis at 1 and -1. I think that makes it pretty obvious what kind of shape is in the middle. What is happening right now? What is going on right now? So what kind of shape is going to be in the middle? Parabola, quadratic of some. It looks like a parabola. Technically, it's not because it, has to approach that asymptote. But you already know it looks like that. Let me tell you right now, I am not surprised one little bit by that shape in the middle. Anybody see why? The squares. Because both the top and the bottom are x squared graphs, and then there's no other x's, both the top and the bottom are even functions, which means overall, this is an even function. It must be symmetric over the y-axis. That means whatever happens on the left side is also going to happen on the right side. So I don't need to plug in x equals 3 and x equals -3. I can just pick one because they must be symmetric. Let's go with x equals 3 so I don't have to mess with a negative number. Y equals 2 times 9. That's what I get when I plug that 3 in and square it. And then minus 2 over, again, plugging that 3 in, squaring, minus 4. 18 minus 2 is 16. And 9 minus 4 gives me 5. That number is Even if you didn't have a calculator, is that number bigger than 2 or smaller than 2? Bigger than 2. So what that tells me is all the way over there at x equals 3, I exist above the horizontal asymptote. Since I exist above the horizontal asymptote, the graph must look like this. Yep, because it's x equals 3.2. Excuse me, y equals 3.2, so I'm above. And since it's an even function on top and bottom, the whole thing is even, so it has to be symmetric over the y-axis. Ta-da, just like that. Woohoo! Pretty neat, huh? Looks like a sad face. Questions, comments, concerns? Please ask away, guys. I'm here for you. No? Everybody's ready for the last example?
I have a question.
Yes! What can I do for you, ma'am?
On the homework, because for some reason I thought it was due today, it says to find all the discontinues. How would you write that out?
Discontinuities? Oh, those are the vertical asymptotes. So you just write x equals -2, x equals +2.
All right.
And the last example, I really like this example because it allows us to practice some old skills. Oh boy, look, check it out. I got a cubic in the numerator. We get to factor it. Psst. Now, if I was a mean old guy, I could have given you a cubic that doesn't factor by grouping. This one does factor by grouping. You're welcome. Because I could have given you one that forces you to use the P over Q and Descartes' sign and synthetic division or Mater theorem. Could have been a big meanie. But no, this one's going to factor by grouping. So lucky us. There you are. So it's been a while since we factored by grouping, right? Algebra 2, probably the last time you did it. The way this works is the first set of blue parentheses, you're going to look for a GCF. The thing that the first set of blue parentheses have in common is x squared. GCF of x squared will be pulled to the front. It's going to leave behind an x plus 4. Now the second set of blue parentheses, what do those two things have in common? -1. I don't know if anybody's ever told you this, but if this thing right here is negative, the second GCF is automatically negative. So -1 comes out, leaving behind an x plus 4. There. And now we just get to regroup. Top is x squared minus 1 times x plus 4. And the bottom is x minus 1. Now, someone in first period asked me, where did the other x plus 4 go? And you know what? It's a reasonable question. It's been a long time since you learned how to factor by grouping. It's been a long time since you had to do it. So here's how I explain it. I go, okay, well, check it out. What if we treat these products as a single object? So now I have 2 green rectangles. And I say, what do the 2 green rectangles have in common? Obviously, it's this x plus 4. So I say, well, can't we just treat the x plus 4 as a GCF and remove it? And when you pull out the x plus 4, what's left in the boxes is the x squared and the minus 1. That's how you factor by grouping, in case you've forgotten. But that's why it works. Now, normally you'd be like, woohoo, done, yay, clicking my heels. I factored. Except for crud. That numerator still has a difference of 2 squares in it. So when we're not finished yet, that x squared minus 1 still factors. We just had one of those. That difference of 2 squares will be x plus 1 times x minus 1. And then I have this x plus 4. All over x minus 1. What do you see? Yeah, this is going to happen. Let me ask you a question, though. Is this graph actually a quadratic? No. By definition, it's not. It's a rational function. You have prior knowledge. You know from the very, very beginning, there's one very specific number that you're not allowed to plug in for x. What is it? You can't plug in x equals 1. You're not allowed. If you plug in x equals 1 at the very beginning, something really scary happens. Not only are you dividing by 0, it's 0 over 0. That's not undefined. It's considered indeterminate. Think about that. How many times does 0 fit into 0? Mind blown. So at the very, very beginning of the question, not the end, nobody cares about the end. At the very beginning of the question, x is not allowed to equal 1. That means no matter what you simplify, x is not allowed to equal 1. It doesn't matter that it ended up being x plus 1 times x plus 4. X is not allowed to be 1. So the question becomes, well, what would y have been if I was able to plug in x equals 1? Okay, well, here's what would happen if x equals 1 was allowed. You would actually be plugging it into here. So if you could plug in x equals 1, what you would get is that y equals 2 times 5, which is 10. That means there is a problem on your graph specifically at the coordinates 1, 10. Elena, this would be a discontinuity. But it's not infinite, is it? It's a single point. So what do we call that? Removable discontinuity. Specifically, I removed an x minus 1 from the function on the top and bottom. It creates a removable discontinuity, a hole in my graph at the coordinates 1, 10. But other than that hole in the graph, it's a quadratic. It looks like a quadratic with a hole poked in it. It doesn't have any vertical asymptotes, and guess what? It doesn't have a horizontal asymptote either. It's simply going to be a quadratic with a hole in it at x equals 1, y equals 10. I mean, you can find the x-intercepts. That's pretty darn easy, right? Crosses the x-axis when x equals -1 and x equals -4. And if you really cared, you could find the y-intercept. Does that say? Yes, let's find the intercepts. All right, y-intercept. So for that one, you just plug in x equals 0, which is just going to be 1 times 4, or 4. Come on, active panel, please catch up with me. There. Time to sketch a graph. All right, so we know we have a point at 10. So how about this? 2, 4, 6, 8, 10. Let's count by 2s on the y-axis. Count by 2 on the y-axis. On the x-axis, let's go by 1s. There's -4, there's -1, and I got +1 there as well. Okay. We know for a fact we have an x-intercept at -1 and x-intercept at -4. We know for a fact we have a y-intercept at y equals 4. And interestingly enough, we have a hole in our graph and removable discontinuity at the point 1, 10. So don't color it in. It's a hole in the graph. It doesn't exist there. And there you go. Let's connect your dots. You know that it's a parabola because x plus 1 times x plus 4, it will look like x squared plus 5x plus 4. If you wanted to be really, really specific, you could figure out where its vertex is, its quote-unquote vertex. It'd be halfway between -1 and -4, at -2.5, if you cared. I mean, since we mentioned it, why not? I had to say vertex because it's not really a parabola, is it? It is a rational function that simplifies down to a parabola. The vertex is going to happen when x equals -2.5, because that is halfway between the -1 and the -4. We just need to know what y would be if you plug that in. First set of parentheses is negative 2.5 plus 1, negative 1.5. Second set of parentheses is negative 1.5 plus 4. Was it 2.5? Did I do my math right? Something's wrong. Negative 2.5 plus 1 is negative 1.5. And negative 2. Oh, it's 2.5, not 1.5. I'll be okay. Let's try this one more time. Come on, active panel, catch up with me. No, it's not the panel, it's the computer. It's because I'm recording the lesson. It bogs down the video processor. Anyway, so negative 2.5 plus 4 gives me positive 1.5. There we go, that feels better. And negative 1.5 times positive 1.5 is negative 2.25. Yes? I think so. Yeah. Yeah, it feels right. That feels right. Okay, where's that? Well, how about negative 2, negative 4? So we're here-ish. Yeah, like that. And then parabola. Oh, crud. Let's try again. I can do this, I swear. Parabola. There you go. Ta-da!